Right, so today I'm going to be talking about research and development, R&D within the defense industry, and sort of just more generally. This is a bit of an overview. So, as you will probably know, the defense industry creates products which are by necessity technologically advanced. So, even in systems that are designed to aid the modern warfighter in ways that are, I guess you could classify them as non-combatant, radio equipment, that sort of stuff, and actual systems for logistics, the systems themselves, the systems developed, are very technologically complex, and if not technologically complex, then certainly complex on their own. So, there really isn't anything that the defense sector or industry produces that is not advanced, and advancement may require R&D. So R&D is research and development, and I think a good way to sum it up is in a manner that someone once summed it up to me. So I was talking to a supply chain manager for a large, unnamed defense firm, and he said this about R&D in an email to me. Everything in defense is super complex. Financing is really tricky. Supply chains are harder than in any other industry. The tech we make, the way we procure, and the logistics behind it are super complicated. But the thing I try to remember day to day is that such complexity is necessary. The aim of R&D is to develop something that may be incredibly complex, but that can be used, fixed, and resupplied in the most simple way humanly possible. So, our aim at the defense firm that, I'm not going to detail, is to take the complex problems of certain organizations and try to solve these simple needs while ensuring adaptability and versatility. And that's precisely it. And in order to do this, you need R&D. You need to be able to turn that complexity into simplicity, and you need to have that inherent complexity in the first place. I guess you'd say complexity in the way it works and simplicity in the client-facing solution at the end. And it's all a process. So, R&D really, in short, it's trying to find the best possible solution. So, it may be massively complex, but the fact of the matter is it's often trying to solve a small number of problems, or a very limited number of problems, or even just fulfill a single purpose. And so one has to make this client-facing end as simple as humanly possible, and as functional and as effective as humanly possible. So, in this sense, one might even be able to classify divisions and departments of a firm, like marketing, logistics, optimization, as a part of research and development. It really is anything that performs that sort of function. They may have their own teams to do so. They may have their own R&D teams. R&D does go beyond the physical. I really cannot stress that enough. Inherently, what we're trying to do is optimize systems for product and operations. It's incredibly important in achieving future growth and maintaining a relevant product within the market and a relevant firm within the market. There is a massive misconception about R&D that within the domain of high-tech firms and pharma companies, that's it, effectively. That other firms don't perform R&D, that it's only these enormous physical product firms, these behemoths of industry that perform R&D. That's simply not true. The fact of the matter is most consumer goods companies and a lot of other firms that have a product, and most firms do, they dedicate a significant part of their resources towards developing new versions of products or improving existing designs. And that's rather important, I think, and the systems within the firm itself. So if we look at the end goal of R&D, it's often thought to be the development of something, and that's absolutely true. But in the vast majority of cases, particularly for defense firms, the value of carrying out these processes is the development of proprietary systems, and that's really a key word. It's the development of something you can call your own and continue, because that's an investment in the future, and down the line that's going to be incredibly valuable. So it's the development of proprietary systems and technologies. Over a long period of time, over the long term, this leads to proprietary development, which then leads to certain product lines which effectively make up brand. They build reputation, and they constitute sort of brand-associated innovation, particularly with technology, which is good for the brands and actually for the general technological advancement of mankind. So, positive thing. Naturally, what all of this means, what development really means, is there has to be a lot of research and development in order that firms might engineer products and come up with good ways to deliver them, particularly within the defense industry, considering that there are a lot of considerations in delivering the product itself and the manner in which it operates, which is pretty specific, and it's got to be able to operate under a lot of different types of strain and in a lot of different scenarios, and still fulfill its function well, effectively. It's got to be well engineered. So, to sort of go over it, R&D, at its core, whether it's making tech or simplifying logistics, utilizes the scientific method to operate. At a basic level, firms have their own, perhaps not proprietary, but they have their own specific manner of operation for R&D to optimize their systems and to make it fit the firm as best as humanly possible. But from a basic standpoint, it uses the scientific method, which is effectively, this is taking me back a little bit, asking a question, sort of finding a need about something that is physically observed, and in this case, often for the defense industry, that is the active observation of the needs of the government, the MOD in the UK scenario, and actually often going after what they are specifically asking for. Next, you have to effectively do background research, learn what we already know about the topic, and how you can effectively build on it. You have to utilize past technologies in order to research something new. Then, of course, you've got to construct some sort of a hypothesis, and then test that hypothesis, and then you analyze the data from the experiment, the test of the hypothesis, and you draw the conclusions and improve what you're doing. And you do that over and over and over again, and communicate the results to others in order to build something that is worthwhile, and build something that is going to be worthwhile to the firm. So, in the defense industry, generally, research applied is not basic, it's applied research quite literally, and both R&D work in a funnel sort of structure. So as I was saying, you have this end stage, which is the communication of results, which is incredibly important for R&D in defense. Because unlike some other industries where you have a singular team developing a singular product and they sort of just go for it, generally within defense you do have, team something, but you have different sort of subsections which are a direct funnel amalgamation that links to other certain sections. Research projects, is what I'm trying to say, are not done in a vacuum. They're not done in the abstract, but they're working towards fulfilling certain complex systems purposes, which many sections often have to work together, communicate on, and the scientific method in this scenario has to be implemented evenly across those sections, across different projects, so that these different projects can synergize, work and communicate with and work around each other. And that is pretty essential if you're developing something that is eventually going to become a product, because it has so many different advanced and complex parts to it. And so in developing this final sort of more simple client-facing solution, one has to work together in order to ensure that work works together. So it can get very complex, considering that there are long-term projects as well, and you have these teams communicating with each other, working with, around, and integrating technologies into each other's projects, alongside the short-term projects that sort of have varying temporal range and operational size. So it's quite a coordinative feat. And it's not the sort of classical idea necessarily of, a room full of scientists waiting in a basement, ambling around, mixing conical flasks of green liquid. There is a lot of corporate oversight to it, not only because what you're dealing with, the certain materials, products, and solutions are, often not available to the public. They have special procurement and logistics considerations, but also because necessarily you have to organize these teams in a manner that short and long-term teams can operate together, and things can be developed in the long and short term, and research can be done to aid both simultaneously, maximizing effectively the input that one puts in, which is the cost. So that is what R&D is, but the question really is, how does it operate? Conventionally, I think the average firm spends something like, it's below 5% of revenue, and that is revenue considering that, it's direct transfer as opposed to profit. Defense firms, despite being far larger and spending varying amounts on research and development, it's generally assured that these firms operate well above the average benchmark for firms in general, considering the sort of complex solutions they're making, how technologically involved and advanced it is, and the fact that there is necessity in the precise products and materials that defense firms develop. So there's a lot more consideration for R&D within the defense industry. And obviously the cost is going to be significantly more than in other firms. And the idea really is to optimize that cost and balance that cost with, its output, I guess. So we've said that defense firms spend a lot more than a lot of industries on research and development, meaning that R&D is incredibly costly. Really staggering amounts for these really large firms that develop a lot of products, that develop a lot of programs in unison, often, and employ organization to, synergize them. So they're incredibly costly. You've got different resources, you've got the logistics behind it, the coordination, the specialized skill sets, actually, that are often needed for the sort of engineering and logistics considerations that are needed, maybe even specified clearance. And as ever, R&D is a balancing act with this. So firms try to optimize cost with these considerations in mind by balancing development and researching their own component systems within their own research and development departments, and also utilizing other systems available in the market. And often on any sort of competition, on any large contract, on ships, there is an amalgamation of other systems that are implemented. So there are certain engineering procedures that have to take place in order to make it compatible with general models as well as the logistics procedures with other firms. In any case, there are also considerations with sort of specific tailored nature of what one's developing. The idea that if contracts aren't won, then often the research may have been for nothing, because whatever is coming in will go into service and it will remain there for quite some time. So the thing you'll have to develop will have to be far more complex, far more advanced than it currently is. And this can often create quite a lot of worry, because there's a lot of overhead and not necessarily an assurance that the result, because it can't even be put on the market, because it's a very specific, limited market, they're not even sure that this cost will be, paid back, because there is no assurance that it can even get to market, the product that is developed. So costs are effectively managed and seen as investments in future capability. A developed product tomorrow, which can continue, as we've said, for a long time, more than recuperates losses on research and development, meaning research and development actually works a lot with sort of contract bidding, as it were, because you really have to ensure that the specific research and development is articulated in order to win that contract and it not be for nothing. So often this can be utilized, as I said, to win contracts, and the research base which they have done to win a contract, if they do win a contract for these various firms, can then be built on and used to upgrade their specific proprietary technology for contracted units, components, or materials. And if this is done successfully, as large firms have proven that they can do, the initial cost of setup of R&D departments, the really quite high cost associated with research and development processes, it can be recuperated really quite quickly and really quite dramatically. The initial cost setup can be quickly moved past, and the rewards of sort of flexibility, adaptability, versatility from one's own facilities is a reward that can be reaped, and then that can be built on. Again, it's not that one comes to the end of a particular research and development project and that is simply the end of development, full stop. If one wins contracts, one can use that research and development to build upon. And that's really where the value lies, in it being an investment into future products and future advancement in technologies, and therefore future profit, ideally. So I think I'll leave it there. Hopefully that wasn't too much of a word salad, but there we go.